All right, so 8e is multiples of pi over 6 and pi over 4. Oh yeah, I did mine all. Okay. That was so disappointing. I wish. Okay, so let's take a look at our unit circles before we even get started here. Locate pi over 6. How many degrees is pi over 6? 30 degrees. Okay. And how many degrees is pi over 4? So, kind of a basic question here, but what does multiples mean? What does the word multiples mean? Yeah, numbers when you multiply. So, like, for example, if I take pi over 6 and times it by 2, that's 2 pi over 6, which is pi over 3. So, pi over 3 is a multiple. How big is pi over 3 in degrees? 60 degrees. So I'm hoping that these numbers kind of jump out at you as being familiar. I know we're not as familiar with the radians. I mean, correct me if I'm wrong, but you should know a bit about 30, 60, 90 triangles, right? You should know a bit about 45, 45, 90 triangles. And those are the types of triangles that are actually made on the unit circle. Like, I know they don't look like triangles, but you can make triangles by drawing like a line straight down. You can make 90-degree angles, and you've got these 30, 60, 90 triangles. And we'll go between radians and degrees. So keep in mind, if you use your calculator, you will have to switch between the two. You've got this unit circle. Remember, I told you we're not looking to take that away from you. Like, that's something that you can use in this class. But we can also do some things by hand as well. So if you have not already drawn your stat box, please go ahead and do that. We were learning more about as these years go on, or the year went on. So we're starting with the multiples of pi over 4, or, as we just mentioned, 45 degrees. So we can have this right triangle here, and when we have that 45-degree angle, if we think of our legs as being 1 unit long, then our hypotenuse is the square root of 2. Now, if we look at the unit circle, let's see if my circles get better today. It's a little bit differently, but if this is 45 degrees, then we would have 1, 1, square root of 2. So it's oriented? I'm not sure.
It's turned around.
It is turned around. So it's slightly different than the one we have right here. But do you guys see what I was talking about? How you can make that triangle on your unit circle? And then when we talk, I know we didn't like spend a lot of time like reviewing this, but we all know SOH CAH TOA at this point. So you can find your sine, cosine, and tangent by doing like opposite over adjacent and so on. So for example, if I wanted to do the sine of my 45-degree angle, or let's say pi over 4, using those radians, remember that would be opposite over hypotenuse, so I'd have 1 over the square root of 2. Now, when you look at your unit circle, does it say 1 over the square root of 2? What does it say? And why? What's going on? Like, why? We just did this. We did this right here, but like that's not what's on the unit circle. And I heard someone say the magic word back there. Yeah, they rationalized it. So 1 over square root of 2, if I wanted to rationalize it by timesing by the square root of 2, I end up with square root of 2 over 2. You guys need to know that those numbers are the same. So even if you want to, write something at the very top of your unit circle that just says square root of 2 over 2 equals 1 over the square root of 2 or something like that. Just keep that in mind. I know I mentioned this sometime this week or last week that the IBs doesn't so much care if you have a radical in the denominator. So if you look at your unit circle, you're going to see this, but if you look in the back of the book, you're probably going to see this one. Okay? I just want to make sure we're good. Are we good? So kind of what I was just going for was, remember that with those multiples of pi over 4, the number 1 over the square root of 2 is important to remember. Also remember the signs are determined by the quadrant location. So if I stick with the sign of pi over 4, if I have the sign of 3 pi over 4, it's still positive because sign is positive in quadrant 2. But if I have the sign of 5 pi over 4, I end up with negative because I'm in quadrant 3. So keep in mind that those quadrants change those signs. Cute little worksheet, Mr. Fairhead. So up next, I bet you can guess what we're going to talk about. 30, 60, 90. Does anyone have strong feelings about the special right triangles? Never remember.
I don't have special for any geometric shape.
That's sad. Just kidding. I like geometry. So I usually feel people like either hate them or love them. Try to learn to love it. Okay. So here we've got multiples of pi over 6 or 30 degrees. 60 degrees, we already mentioned, is also a multiple. And so, part of this picture got cut off, so let me draw that in. Square root of 3 over here. So your short leg is always across from that 30. If your short leg is 1 unit, then your hypotenuse is 2 units, and your longer leg, which is across from the 60, is a square root of 3. So this picture right here would be like on our unit circle if we had that 60 degrees. So we would have 1, square root of 3, and 2. But it also still works if we have like that 30 degrees. We would just make that short leg still 1, that would be square root of 3, and that would be 2. So 60 degrees and 30 degrees both have those same values or that same relationship to their sides. So just like we talked about how you can do a sine, cosine, or tangent, we can do the same thing here. We should remember SOH CAH TOA. Does anyone have any tricks to remembering SOH CAH TOA? Yeah? Yeah, absolutely. Do you have any tricks or you just got it?
SOH CAH TOA.
It just is? Okay. Just curious. If anyone had like any stories or anything that helped you remember it.
Most people.
Oh my gosh.
You what?
I write like so
Okay.
that I know that.
Alright. So you keep the ratio in the right order. Like a what? Teepee pole. Okay. Alright. Okay. So keep in mind that the important numbers to remember are 1/2 and square root of 3 over 2. And again, signs are determined by the quadrant location. And if you do have circle. So if you look at pi over 6, sure enough, cosine is square root of 3 over 2, and sine is 1 half.
Thank you.
So those numbers are also right on your unit circle. And again, just like we talked about, you can use a smart trig class or a silly turtle crawls or whatever it is to help you remember where the signs are, like where it's positive and where it's negative. I know we can get tangent from doing opposite over adjacent, but then also keep in mind that tangent is sine over cosine. So whichever way you want to evaluate tangent, just remember you've got those different ideas there. Okay. So keep in mind, what's pi over 2? We haven't really talked about that yet. You can look at your unit circle if you're not sure. Yeah, pi over 2 is 90 degrees. So keep in mind that 90 degrees sort of rotates between 0 and positive negative 1. So we can see those numbers on our unit circle. For those other multiples of pi over 4, once again, sort of repeating, kind of summarizing what we already talked about, positive or negative 1 over root 2. And for other multiples of pi over 6, then we've got plus or minus 1/2 and plus or minus root 3 over 2. So just kind of remembering those things. And that is taken straight out of your book, so if you didn't get that and you want to jot it down, just leave yourself some space there. Let's look at these cute examples we have. So without using a calculator, evaluate the sine of 30 degrees and the cosine of 60 degrees. So there's two ways to do it. I'm going to start with the long way, and then I'm sure some of you guys have already figured out the short way. So if I keep in mind those special right triangles, if I've got 30 degrees, then I've got 1, 2, and square root 3. So without using a calculator then, I know that sine is going to be opposite over hypotenuse, so the sine of 30 degrees equals 1/2. I can use the same triangle for 60 degrees, so the cosine of 60 degrees is adjacent over hypotenuse. So I can do the cosine of 60 degrees equals, also 1/2. So that's interesting there. So we can draw that triangle, we can sketch that out, especially if you are like in the middle of the ACT or you're on the IB exam and you don't have your own unit circle in front of you. That's a good strategy. But what's the quick and easy way? Looking at your unit circle, right? So if I look at 30 degrees, sure enough, the y-coordinate, which is sine, is 1/2. And if I look at 60 degrees, sure enough, the x-coordinate, which is cosine, is also 1/2. So I'm not taking that away from you, but there are situations outside of this class where you won't have it, so I just wanted to remind you of sort of the long way with the triangles. So, trying not to use a calculator there. So this one says find all angles between 0 and 360 with a sine of square root of 3 over 2. And so there are a few different options here as well. So one option is the quick and easy way of looking at your unit circle, right? So if I have to find all the angles between 0 and 360, that's all the angles on the one unit circle here. And I can look at all of those, so I can see that 60 degrees has a sine of 3 over square root of 3 over 2. So just straight off of the unit circle. And then if I keep looking, so does 120 degrees. So that's one way to do that right on the unit circle. The other way would be to, if you look at your unit circle, you know, or if you don't, you can always draw that triangle again. And kind of, we know root 3 over 2 has to do with 30, 60, 90. So if we start with that, we can come up with, sure enough, 60 degrees opposite over adjacent. And then what did we talk about yesterday with the relationships to different quadrants? If I didn't have, if like it wasn't on my unit circle, remember the relationship with sine is you would do 180 minus your angle. So sure enough, you would get 120 degrees. So whether you go straight to the unit circle, whether you kind of push yourself to sketch that triangle, we can use what we did yesterday, kind of connecting those two things. The one thing I do want to say is make sure you do pay attention. It says between 0 and 360 degrees, so we want our answers in degrees as well. Now, if it said between 0 and 2 pi, you would not write 60 and 120. If it said between 0 and 2 pi, you would want to make sure you write pi over 3 and 2 pi over 3. So keep in mind that even though it doesn't say give your answers in degrees, it's setting you up to do that because of what's the information that's in the question. Okay, I know I'm kind of doing the most, showing more than one way, but hopefully you guys are still okay. And we got this one. All the angles between 0 and 4 pi with a sine of negative 1. So one clue here is that we do want to give our answer in radians because it says 4 pi. Oh, what does that even mean, going all the way to 4 pi?
So this means that you multiply it twice as in 360 degrees, twice also 750 degrees, so that's twice around the circle.
Good. So I'm already kind of switching into degrees because that's what we're more familiar with, but he said it exactly right. Twice around the unit circle, because once around the unit circle is 2 pi, so we have to go twice around the unit circle. And we'll talk more about that as we move forward into this, trig section that we're going to do for the next few chapters here. So we got to kind of look at, first of all, what angle has a sine of negative 1/2? No, wait, not half. Where did I get half from? Negative 1. Wait. Not cosine, sine. So 270 degrees, except for we want to give our answer in pi, or in radians, so we would say 3 pi over 2. That's one angle. Now, does negative 1, the sine of negative 1 show up anywhere else? So how many rotations, we didn't talk about this yesterday, but how many rotations do you think would have to happen, or where would it happen again? We'd have to go all the way around the circle one full time. So when we talked about sine was pi minus the angle, and we talked about cosine was 2 pi minus the angle, tangent was pi plus the angle. Well, when we're working with these values that are multiples of pi over 2 or multiples of 90 degrees, we have to take a full rotation. So I'd have to take this 3 pi over 2 and add one full rotation to it. Now, we don't want our answer to be a decimal here. We want to be able to keep pi in our answer. So how do you think that I could add this just by hand? Without going to a calculator. Like, what's in the denominator of this 2 pi? So how can I make this have a denominator that's the same as this? Yeah, multiply that by 2 over 2. So then I end up with that 3 pi over 2 hasn't changed, but 2 times 2 is 4, so I have 4 pi over 2. So now that I've got those common denominators, the denominator is 2, but I have to add up my numerators, so 3 plus 4 is 7. So one angle is 3 pi over 2, another angle is 7 pi over 2. I don't remember like the exact section off the top of my head, but I know that there are some sections in a future chapter that will be a lot of this kind of stuff where you have to find those other angles between like a greater, what do I want to say here? Like interval between just, besides just 0 to 2 pi, maybe going all the way to 4 pi, going to 6 pi, like that's coming in the future, so just kind of keep this in mind here. Any questions? So then our stat box just says, what should you remember? What do you guys think? What are some things worth remembering or trying to remember? The triangles, the sine, so a smart trig class or a silly turtle crawls. So remembering those signs is really important. Okay. Okay, well, I think those are all good things to remember, and here is your assignment. These are just, remember that a lot of them you can get right from looking at your unit circle, right? So don't panic. Some of them might be a little different. Remember, you got to think a little bit more and kind of integrate some things we've already done, so keep that in mind as well.